Hi engineers, and we're going to continue today with making our glider. I'm going to show you what we've done so far and what we have yet to do. We first wanted to figure out where on our spars to put the ribs. You can see here I have marks every 2.5 inches, and I'm starting at 2 inches. Now, metric, I'm starting at about 5 centimeters and spacing out about every 7.5 centimeters after that, okay? There's a reason why I've chosen this distance, and I'd like to show you that, but first, let's get down to a little bit of work here. We'll check that. Yeah, that's good. We have one more hole to drill, and I wanted to show you a little trick that I did not do last time. I've already put it in, as you can see, so it rides up, but now I'm going to go the opposite way and push down a bit, and that helps widen the path. How do I know if it's wide enough? I will take one of my spars and slowly rotate it to push it through. Did you see that right there? It pushed right through. It goes through the other side now, and that was my final drill, was using the spar itself. Now this guy is about number 3. I've got them in order, and we'll line them up right here for you. So there you can see from longest to shortest, and we will put the smallest one in first. Why? We've got to slide it the farthest. So we'll get our marks lined up here and start putting these guys on. I put them on 2 at a time, hold the spar, and then I can slide these through to the places I need. There we are. He is on his mark, and the smallest is in. We'll do that for all the rest. To do them one at a time like this, if you try to move the spar in one at a time, they will wiggle and get out of shape, and that'll widen the hole, and we don't want to do this very often. Okay, we're going to double check there, there. You can imagine if you hurry this too much, how much trouble you could really get into. But notice as we get a couple of ribs on, this becomes more stable here. It's becoming more firm with each piece that we put in. Two more to go. And then the last and the longest one. Now we're beginning to have a wing. There it is. It does want to warp a little bit, and it should want to warp a little bit. It's not reinforced yet, and to do that, we need to reinforce our ribs, which are attached to the spars, with something called a stringer. This is 1/16 of an inch, or about 1.5 millimeters, and we'll make a little cut on the top of each of these ribs so that these stringers can fit in just like that. And we'll put about 3 stringers on the top, 3 on the bottom, and we're going to put 1 right on the nose here to be the leading edge, and then we'll sand that all down. The stringers add stiffness to this. It gives it a lot of strength and rigidity. But more importantly, it gives us another place to attach our wing surface, which is going to be this red tissue paper. We'll have to shrink the tissue paper onto that, and I will show you a couple of ways of doing that by spraying a solution of alcohol and water onto it, and that will make the tissue paper shrink. Then we're going to use something called dope. Butyrate dope has been used in aviation for a long time. It will tighten up paper and cotton. And that was oftentimes the fabric used on wings was what's called grade A cotton, not made in America anymore. It doesn't have much aviation use except overseas from some of the older airplanes. So now you're seeing that our wing is beginning to take shape, and you can see how thin this piece of balsa is, and you can also see the rectangle cut. This was an idea for a spar here. This is 1/8 of an inch. And you can see that it is cut on the rectangle because if they tried to mill it into a circle, I really think that it would fragment and not do well. But this could be used as an ultra lightweight spar as well. And I have done that in the past. The only problem is we don't want them too long because they will really begin to flex and put a lot of pressure on the wing root. The wing root is where all the pressure is. We're going to be carrying the fuselage weight here. The lift will be bending the wing like this, and that wing root has to be strong. Unfortunately, balsa is very strong for its weight, but these are going to be a lot stronger, and we're going to have a lot better airplane here. All right, let me move the camera back up. We're really starting to make some inroads with this. As you can see, we have a good, this is going to be the port or the left wing. Here's the wing root. And then we'll add these out here every 2.5 inches. 1, 2, 3, 4. Probably need another 6. By the way, every piece of balsa has an identifier, every piece of wood, and this is tough to get off right here. You can see it's got the coat on it. This paper does not tear very well, and I haven't really found a good way other than maybe I don't want to soak it because I might damage the wood underneath, so I've just been slowly peeling it back with my thumbnail. As you can see, it's taking a long time, and I've only got about half of this one done. Such is the nature of working with small wood. But we now, folks, we're getting a wing, and this glider is going to really be good. So stay tuned, and we'll start filling out the ribs, putting in more stringers. Once again, as soon as I can find more stringer material, like this. As you can see, this is not very straight. Fortunately, by every 2.5 inches, I will be able to straighten it out by putting it in the notches. That's another reason why I want these reasonably close together. It'll also keep the tissue wings from flapping too much. I really want that taut, and I want it well supported. So I felt 2.5 inches or 7.5 centimeters was going to be about right. All right? Thank you for watching. Please like, share with a couple of hundred of your closest friends. Let everybody know that we're having fun doing old-fashioned construction techniques to make a very high-performance glider. All right? Thanks so much. Bye.